I'm Charles, and I'm on a mission to find what's inside everything. To help me get my answers, I have an industrial CT scanner. It takes a whole bunch of X-ray images from all around a subject, and then builds a 3D model revealing every internal detail. Today, we're looking inside of a sealed lead-acid battery. I'm kind of curious to see if we can see anything inside of here. There's two ingredients in a battery like this, and one of them is lead, which is famous for blocking radiation. So we're going to scan it as long as we can. Lead-acid batteries have been around for over 100 years now, and I don't think they're going away anytime soon. They're simple, cheap, safe, and more or less reliable. I want to see that simplicity laid bare, but first of all, can we see anything in here? Past that, what's the structure look like inside of this? Let's see what we can see. This is a scan of our sealed lead-acid battery, which weighs about 5 pounds, which is pretty good for the size, and is full of lead. Let's trim away the plastic a bit and see what we can find. If we look at this from the top, with the cross-section, we can actually see that the battery is split into 6 cells. You can see a split down the middle, split here, split here. Now 6 cells makes sense because this is a 12-volt lead-acid battery. And each cell of a lead-acid battery is about 2 volts at nominal charge. So we should be able to see the actual structure interconnecting those. And sure enough, we definitely can. Yes. So in between each batch of cells, we can see the tabs connecting the plate stacks between the cells. So here we have one lead, which is going to be our negative. We got our one lead, it's going to go in, connect to a bunch of cells. Then we have the opposite side of that cell, comes through here. Opposite side of that cell comes through here. Opposite side of that cell comes through here. And then we have these little jumpers here in the middle, and those are taking cell 1 and connecting it to cell 2. This is taking cell 2 and connecting it to cell 3. This is taking cell 3, connecting it to cell 4, and then 5, and then finally 6. That's actually the full structure right there. What makes it a sealed lead-acid battery? Well, traditional lead-acid batteries would have ports on the top so that you could refill the acid as it boiled off and evaporated with use. And a sealed lead acid doesn't have that. It's, well, sealed. This means that you don't have fluid evaporating, which means you don't need to replenish it. So, instead, it gets filled at the factory and then capped off. And you can see, at just the right layer here, where the top lid of this whole structure actually gets pressed into place. And in doing so, seals them all shut, because these are the fill ports for each individual cell. And of course, this is an electrochemical cell, so you need to isolate each individual cell in the stack, in the battery, from one another. And sure enough, yeah, you can see the plastic surrounding each individual set of fins. The question I want to figure out is, how is this manufactured with these seals? You can see we have our lead plates here, which are a little hard to make out on the 3D scan. And then eventually we have the seals. If this is an injection molded plastic case, well, how are they getting the lead on the inside before they batten the hatches shut if the holes in the top are only that big? Well, one hint is we can look at the damn thing. There's a seam right there. So this thing has a lid. And I suspect that the lead plates and all the wiring in between them is actually integral to that lid and then dropped into the bucket. Can we find the seam line? Sure enough, we can. In fact, we can find a layer that's right between the seams. You see how it's kind of shadowed right here? That's because we're at a bit of an angle relative to that piece of geometry, so it's only showing up on half of this scan slice. Now, they've made a very compelling seal between those two, and that's because, well, that could be packed full of glue, it could be ultrasonically welded, it could be thermally welded, it could be any combination thereof. But these are essentially a single piece of plastic now. Our steps here are we start with a bucket with 6 slots, but a bucket nevertheless. We then assemble and weld into place our lead plates into the lid of the bucket. We drop the lid of the bucket into place, weld it on, then go up to the top. We pour in our acid to complement the lead in our lead acid battery through these 6 ports right here. Once it's all filled up, then we put on this final top layer. It gets thermally bonded into place, and you have a sealed lead acid battery. It is kind of incredible that in something made out of this much lead, we can still actually get a fairly decent understanding of what the mechanical structure is. Like, I really wasn't expecting to be able to see right into the middle of the whole plate stack in each one of these cells, but sure enough, there it is. If you enjoyed this video, make sure to leave us a like. And if you want to see inside of something, leave a comment with your suggestion. If you want to support the channel, share this video with a friend, or check out hacksmith.store. And if you want to see inside of everything, get subscribed.